He's the CEO of Energinet Gas TSO in Denmark, and also he's also the president of GIE, Gas Infrastructure Europe, in Belgium. So we have Torben here already. And right, Torben, I will be sharing your presentation from my side, and also the full question is ready. So just feel free to let me know if you need any further assistance. So just give me a second, then I will share the presentation from my side.
Thank you.
Right, can you see my screen?
Yes.
Right, okay, then I will put it on the full screen. Right, so I think now is the full screen view on everyone's screens. And Torben, feel free to start your presentation. And also let me know to flip the slide.
I will.
All right.
Thank you, and thank you for inviting me, both on behalf of Energinet and GIE. I just came from an NSOG board meeting, so unfortunately I didn't attend the previous presentations, but I know the persons and I know the topic. I had the interesting topic of cost-effective H2 infrastructure, and I want you to take you through that, and it will be approximately 20 minutes and then some Q&As and also a poll, as Phoenix just said. So please go to the next slide. I don't know how many of you know Gas Infrastructure Europe, but we are, let's say, an old organization, almost 20 years old, and we consist of 70 members in all of the European Union and also some other states. We are infrastructure companies for gas, transmission, storage, and LNG. Probably we are less known, and to some extent that's, let's say, good for us, because we have, let's say, the operation and investments into energy infrastructure, and we provide security of supply, market development, and green transition. And the less you know of us, the better we are in serving supply and having, let's say, affordable costs, tariffs, etc. So for us, we have, let's say, been very proud to be, let's say, not that well known. But now in the transition, where we are taking our steps away from only focusing on security of supply and markets and also aiming in transition, perhaps it's not so good. So I'm really glad to be here. The TSOs, in fact, handle 20-25% of all European Union primary energy comes through our network, 4,000 terawatt hours on an annual basis. Our storages can store 1,000 terawatt hours, and the LNG terminals, let's say, is connecting the European energy and gas markets to the global market, and thereby, let's say, attracting cheap energy when the prices in Europe come too high. Please go to the next slide. I will take you through 4 steps in my presentation. One is I will go a little into the problem we need to solve. And then I will go to the benefits of the existing gas infrastructure. And then I will touch upon some elements in the need for new regulations. And then I will go into the case of Denmark, let's say, from the 3 above. So please have in mind that in the European Union, we use 13,000 terawatt hours of energy, of which 4,000 is, let's say, natural gas. And then we have 2,500 of electricity, and then oil and coal and feedstock constitute the remaining. And what we have, let's say, discovered during the last 5-6 years is that all of this need to be renewable, and it needs to be going through electrification, either direct electrification or indirect electrification into molecules. Approximately 2/3, from half to 2/3 will be direct electrification, and 1/3 to the half is going to be molecules. And today we have only decarbonized 1/4 of the small electricity sector, which is only 2,500 terawatt hours. And the remaining parts, it's natural gas, oil and coal. So we have the larger energy quantities in front of us and the more difficult energy sectors in front of us, and then adding on end users. So please go to the next slide. So in our interpretation, we have divided the change on hydrogen into 5 categories, because it's important that we discuss the challenges, let's say, in categories that where you have projects or let's say surrounding parameters which is comparable to each other, and don't mix up that we are let's say discussing a backbone when in fact the current project is then only a cluster or pilot. So we categorize all projects, all ongoing activities from pilots into clusters. They're scaling up, interconnectors, backbone, meaning from less than 1 megawatt to some megawatts, 100 megawatts, 1 gigawatt, several gigawatts, and then the backbone when you're interconnected on a European scale. Please also let me remind you that 3 years ago in Europe, we prepared the clean energy package on electricity and renewables, and there we didn't foresee power to X or hydrogen. So in 3 years, we have come from a very fantastic legislative package on a European Union level, and all we talk about now is, let's say, coming on the scene with a very high speed. So we also need to be very careful when we discuss and when we progress. And to some extent, our organization, because we are used to handling enormous amounts of energy, preparing the markets, etc. I think also that our, let's say, core competence is also to guide how we can, let's say, conduct the overall transition. I know that there are many other stakeholders on the scene. Many of those don't have the experience of serving 25% of the European Union primary energy consumption. So that's why I think GIEs and the NSAC is a really important organization. So the different countries, if you go to the next slide, please, are currently in different starting points. So we have the Netherlands and Germany, as you have just seen in the European Hydrogen Backbone study, where you know that there are already existing hydrogen production and consumption, even in Poland, etc. So they are probably already scaled up and they're already on an interconnection level, and they can, let's say, convert the existing L-gas gas system, Netherlands, Germany, into hydrogen and fairly easy be the first parts of the European hydrogen backbone. They are mainly driven by an industrial need for being green. They have the industry, so they can speed up there fast. Many of the other flags here, including my own country, even Southern Europe, Spain as an example, we don't have that much hydrogen consumption. So our development along these 5 categories will be along a different pathway. It will be probably more from a push from the renewable side. In Denmark, we have a lot of wind, offshore wind. In Spain, they have a lot of sun, also onshore wind, and therefore there will be a push from the production of hydrogen. So we might end in the same market situations, we might end in the same infrastructure development, but the value chain have different focuses. Whereas from my country, we have, let's say, a push from the production side, and some of the other countries, they have a pull from the consumption side. This means that if we need to prepare a legislation or framework or revision, it's not only to have a map like the European Hydrogen Backbone, we need to conduct it step by step in these 5 categories, because the right regulation will be different in the 5 categories. Time is for sure a key. So we also need to have, let's say, an adaptive approach, because when you have had your clusters for 5-7 years, then they will grow, they will scale up, and then they might be connected. So you will gradually move from left to right in this presentation here, or on this diagram here. Please go to the next slide. Here we have an even worse presentation where we have gone to 2035. Just a guess, it's 1 year ago, this slide, in fact. But here you can see that many of the countries have moved upwards in the curve. So we have a backbone around 2035, as you have seen from the Daniel Mutman presentation. Storages are very key. Storages we see are probably on the short term more involved in hydrogen projects than, for instance, transmission, because even the smaller projects, the clusters, they need balancing, and they need peak supply on a short-term basis. And then later on, they will need to be, let's say, connected to different consumption segments and so on. Blending is also really important. Blending could be a way forward again, for some countries as a starting point, because you can get rid of, you can, let's say, balance, if you can put the hydrogen into the methane network, but also some countries where you don't have existing, large-scale industrial use of hydrogen, it will take more years for them to mature, and therefore they can use blending on a long-term scale. Digitalization is also really important. We need to handle different gas qualities. We also could have talked about biomethane or synthetic gases and so on. And natural gas, biomethane, and hydrogen, they have, let's say, different qualifications of gas standardization. And therefore, digitalization can assist us where are the different gas qualities. There's also the question whether we should, let's say, have a flat standard, a unique gas quality standard, or whether we should allow different gas quality standards and then use digitalization to guide the end users so they, from a digital signal, can convert their let's say, boilers and industrial equipment to consume the actual gas quality content. Please go to the next slide. So this was about the problem. Now I'll go, let's say, into how we can reuse the existing infrastructure. As Daniel Mutman also presented, we have 225,000 kilometers of transmission and around 2 million kilometers of distribution pipeline, natural gas pipeline systems in Europe today. And some of them are fit for fight already. Some have been previously used for city gas. Others can be, as we call here, retrofitted, the first column. And that is where we take existing infrastructure and we retrofit it to be blended. Can we take 1, 5, 10, 20% of hydrogen being blended? And most of the technical organizations, the tests we have in the Netherlands, the tests we have in Denmark, we are now in fact running full scale in Denmark, 15 to 18% blended hydrogen into natural gas networks. And we see no problems there. Legislation in Denmark provides us to go to 20 or 19.9. But perhaps we might go even further than that. So that's, let's say, one way forward. This will also have a large economic savings because we don't need to invest into new infrastructure. We can use the existing one. In some areas, we will see some industries change from natural gas to hydrogen. So the infrastructure could be, let's say, stranded, and therefore it can be reused for a new purpose, blended. It can also take to the next step, where we repurpose the pipeline, and there we, let's say, do more technical change to the valves, to the M&R stations, to the compressor stations, etc. That requires, let's say, a larger investments. But there we can, let's say, convert the methane system into a direct hydrogen system. And again, here I can also mention if we should prepare either electric cables, overhead lines, if we should prepare new pure hydrogen pipelines, we need to go into the ground, we need to have a rights of way, we need to have new construction projects, and at the same time we have, let's say, infrastructure that can be converted. So it's easier, it's also, let's say, faster to do it this way because we can use the existing infrastructure which is already there. I think that the consumers and the public in general would like to see us retrofit and repurpose instead of, let's say, investing and using the money there. Let me remind you that the transition of the 13,000 terawatt-hours, as said in the beginning, is very costly. So we need to have a strict focus on, let's say, low-hanging fruits and cost-effective solutions. Then the third pillar, that's where we build new energy infrastructure. So not all geographic places we have natural gas infrastructure available. Some of it might also be, let's say, used for natural gas for many decades from now, or biomethane. So it's not available for neither retrofitting nor repurposing, and therefore there will be places where we will go and have building new infrastructure. If you take the key figures from the European Hydrogen Backbone Study, it was, let's say, 25% of new building, 75% of repurposing and retrofitting. And the cost savings, I hope Daniel also said, was, let's say, between 50 and 2/3, 66% savings. You could have, no, I think it's up to 90. So it's from 50 to 90% savings in cost that we can have by reusing the existing, meaning that we only need 10% of the cost compared if we constructed new pipelines. Please go to the next slide. There I try to take these development pathways into our organization. So transmission, we have, let's say, available, and we already know that today it's 10 to 20 times cheaper to transport energy as a molecule form compared to electricity electrons. And as I said here, repurposing at 10 to 35% of the cost. We have just made a study between Germany and Denmark and Netherlands. They have done in other countries. They're also doing. So we need the vision, the European-wide studies, as we see in the European hydrogen backbone. But we also need more detail where we do it more precisely on a national or bilateral basis, where we have, let's say, better estimates. For storages, we can already now convert existing natural gas storages on 60 terawatt hours into hydrogen. And right now, storages are 100 times cheaper than electricity storages in batteries. And this is, let's say, the expectation on battery cost to be reduced towards 2030 and 40, etc. Gas storages are really, really cheap. GIE, our organization, is conducting a European hydrogen backbone study on storages, because we also like to present the vision how storages can be repurposed or, let's say, be used in a new context on hydrogen. And then we have the terminals. We also have done large studies in how we can, both on biomethane and hydrogen, use the terminals both for exporting and importing. And there is technical ways forward, and then we will see reduction of cost. It's not only, let's say, for import and export, let's say, in and out of Europe. It could also be in Europe, so from the south to the north. If you have a lot of sun in Italy and Spain, you might have, let's say, good locations where you could produce electricity from wind or sun, make an electrolyzer and bring the hydrogen to Northern Europe, or by pipe. We need to see what is cheapest. Please go to the next slide. This is about our policy recommendations. I have 3 slides, but I only brought 2, I discovered. So sorry for that, but I will mention the 3rd one. So we will need an appropriate system to regulate this change. So I just said that 3 years ago, we didn't talk about Power-to-X and hydrogen. And now it's the most likely new energy carrier towards 2030 and 35. So we need to change the regulation very fast, so we can receive and develop all the projects which is currently ongoing. But we also need to be very carefully that we not will end in doing it too expensive, nor we will do it, let's say, in a so difficult way that we will lose time, because time is also really crucial towards 2030. So we need an appropriate system to regulate the hydrogen infrastructure, to kickstart the hydrogen market and to achieve the targets of the new Green Deal. So we call on a coherent legislation on hydrogen, which is, let's say, matching the existing gas legislation. We know the gas markets very well. We know how the end users have, let's say, been part of development of the gas markets, and also the policymakers. And I expect that 60 to 90% of the gas legislation could be used in the most mature hydrogen markets. But for sure, there should also be room for, let's say, different solutions. On some points, the hydrogen market will have different characteristics compared to the natural gas markets. But let's say, that doesn't mean that we need, let's say, a completely separate legislation. There need to be large similarities. Also because the consumers most likely will use natural gas today and hydrogen in 2030, and gradually they will shift, or they will shift very fast. So they will also, let's say, have all the experience, where you will have all the liquidity from the existing gas markets. We need to avoid inconsistent roles and responsibilities, so there should be a clear definition of those. Also on the regulatory principles, which should guide the hydrogen markets. We find it difficult to have, let's say, a very fixed regulation on the short term, because we don't know the answers. I don't think that anyone knows the answers. So we think there should be, let's say, a larger room for changing or adapting when we know more gradually over time, and leaving room to maneuver for the member states or regions so they can choose, let's say, the right detailed regulation, which is, let's say, practically best implied on their hydrogen development. Acknowledge and enable the crucial role of infrastructure owners. Our members are here and we are ready to take part of this transition. We are already doing that. But right now we are in fact inhibited or not allowed in the current regulation to take steps along the hydrogen pathway. It's not that we want to do everything. For sure, there should be a clear, let's say, split between production of hydrogen and transport and storage of hydrogen and so on. But right now, most of our members are not allowed, let's say, to engage neither in pilots nor in the cluster projects. Or if they do, they are not allowed to, let's say, collect the money. So we need to have a regulation which allows, which set free the competence and the potential infrastructure, so the existing infrastructure can be part of the development. Retrofitting, repurposing, and newly built is not, let's say, allowed or described in the current legislation. So we need to see, let's say, a way forward there. Some countries, for instance, Germany, they have now, let's say, an
Hi, Torben, are you still with us?
slide with a small figure, please. The illustration.
Right. I think the internet from your side just. Can you hear me?
I cannot hear you. Very little, yes.
Yeah. Right. Can you hear me?
Yes. What are you saying, please?
Yeah, I think the internet from your side just it was just frozen a bit. It was breaking up, but now it's fine. So please continue your presentation.
Okay. So please the slide with the small illustration to the right. The next slide. Yes, this one. So we call for dynamic regulation. So we need a regulation that matches the 5 categories. So to some extent, as you can see on the illustration, we need, let's say, a basic regulation for all entities, definition, roles, responsibilities, and then the more progress the cluster, the group of clusters, or the transmission, or the interconnector over IPs between member states, or genuine regional backbone or EU-wide backbone. On the longer scale, then the regulation need to allow for, let's say, stepping up in complexity and detail. But let's say from our side, we could more or less prepare most of this in building blocks already on the already on the short term. So clusters can start with the basics and very detailed Dutch and German backbone, they can use the more detailed. So unbundling from vertically integrated infrastructure, third-party access should be given transparent, non-discriminatory access rules, and so on. We fear that we might enter a situation where we will have, let's say, a too soft legislation, where we'll have, let's say, that everyone can freely go into the sector, and after the first round, 5, 8, 10 years, then there will be, let's say, a risk that the sector will, let's say, be met by smaller monopolies, and therefore we will see less competition. We will see reduced introduction of new projects, etc. So by having it, let's say, open, transparently, third-party access to all infrastructure, we see that's the best way forward to promote that both producers and end users can see and guarantee that they can be, let's say, connected in the same way. So there might be, let's say, a regulation which, let's say, from 2020, 2025, 2030, and 2040, etc., where we step up and also stipulate that, let's say, that if you are, let's say, an industrial player today and you have a cluster with, let's say, a monopolistic characteristics, then at least by 2030 you need to adapt to one of the other regulatory components, so everyone can see how that the hydrogen market will develop over time. The third slide, which is not about here, that's about financing. This is about how we can, let's say, introduce new infrastructure. We know that all of this is going to be invested either by private companies, infrastructure companies as us, by end users, or by member states or the Commission. And we also know that this might be costly. So if there is, let's say, an approach where we can use the existing companies to start the investments and make it regulated, if we can find ways how we can take natural gas assets and convert them into hydrogen assets, then the more the better, and the cheaper the transition will be. Please go to the next slide. These are the two last slides. So this is on Denmark. Please go to the slide with the Danish flag in the top left. Yeah, this one. So let me start by saying Denmark is special because we started very early. We have 40 years of experience in, let's say, going through a renewable transition. We have had more than 40 years of subsidies for wind, and now we ended, let's say, some years ago where wind became economic. Even the cheapest power production technology, not only because of us, but because, let's say, all the other countries, Germany, Spain, and China, and so on. But at least we started very early. We have had, let's say, a very broad political consensus for the same energy strategy for 40 years. We have a lot of interconnectors, both on gas and electricity, and we also have a lot of renewable potential. So if you see the first small figure there, you can see that our potential is 18 to 40 gigawatt of offshore wind. And the current max peak demand is only 10 gigawatts. So the potential for offshore wind is 4 times larger than the current peak hour for electricity. And at the same time, we foresee that electricity demand and peak hours will increase and increase because we electrify more and more transport sector, heating sector, industrial sector. But there is, let's say, also room for produce a lot of offshore wind and take it to shore. Therefore, we have the concept of energy islands. The government have in the parliament had a majority voting on 2 plus 3 gigawatt energy islands in the North Sea 3 and the Baltic Sea 2 gigawatt. And the North Sea could add up, let's say, with 7 more, so it will be on 10 gigawatt. This is instead of bringing all the individual offshore wind farms onshore, we will connect it on an artificial island. Our company, Energinet, is currently planning how this island could be developed and how it could be interconnected, let's say, to Denmark and other countries. And then there will be made a public-private, let's say, ownership of the island. It will most likely not be our company, but we will own, let's say, the electricity and gas infrastructure on the island. As you can see on the third picture, we have interconnection memorandum of understandings with Belgium, Germany, and Netherlands already signed. So this hub and spoke energy island concept, the other North Sea countries also see that this is a clever way forward. So we will move to, let's say, to an offshore system operator level where electricity will be produced there, and then it will be either consumed in a member state. It will be, let's say, transported to a neighboring member state. It will be, let's say, converted into hydrogen at the island, or let's say onshore at some location in Denmark or in our neighboring countries into hydrogen, and then going through the hydrogen network. So this is the potential, and let's say the main steps politically for providing a conversion from offshore wind electricity into hydrogen. Please, next slide. So within our company, how we unlock this power to X and hydrogen potential. Right now we have 4, let's say, areas where we assess and develop fine solutions. As you can see on the left, we have the landing zones in the power sector. We address how should we take all this electricity onshore. The electricity system in Denmark, even though I said it's really good, it's really solid, we cannot receive all this electricity in any given point. It will be too expensive, and we need to develop the onshore network. So therefore, we will define different landing zones. There will be a use of, let's say, feed-in tariffs to guide the producers of electricity to choose the socioeconomic best landing zone. The electricity TSO also assess currently with all the stakeholders in Denmark how to change tariffs and other, let's say, parts of the network codes on electricity to pave the way for this new consumption, power to X. Not that it will be given all the benefits, but it should also have the benefits that it rightly can, let's say, take. For instance, you can close the electrolyzer very fast, so they don't need to pay for all the same security of supply services as, let's say, ordinary Danes need to for lightning, etc. Then we have the green value, which focus on guarantees of origin for electricity, for natural gas, for biomethane, for hydrogen, and then across their guarantees of origin schemes. We need to prepare a way where you can take electricity into hydrogen, store it out of the storage, and use it as hydrogen, and you have the same green value across the value chain. That green value we also would like to export or import with our neighbors. So, in the end, an EU-wide scheme, not only for the different silos, different segments, but also cross-sectoral. Then we have the clusters. Many of the projects in Denmark also come, let's say, onshore, because we see the development there with some industries, some onshore wind parks, gas storage, etc. And we assess how this distributed power to X can come in, and then in the end, hydrogen infrastructure, the backbone. So what we have done for the last 6-8 years is that we have, let's say, an integrated energy planning. We have the electricity networks and we have the gas networks. We have the power supply, the biomethane supply. We have the end users. We have the heat, the district heating networks, which I can also have a comment on. And then we optimize through all these layers. And then the tariffs, the feeding zones, the market design should reflect how we most socioeconomically can develop our national infrastructure and take all the benefits. And some of the yellow dotted line, I cannot see it here on my own phone, but I know they are there. They are matching what you saw in the previous presentation from Daniel Mutman. And the line coming, let's say, from the West Coast North Sea down to Germany is part of the Energinet Energinet study, which was published 2 weeks ago, just in more detail. Final comment is on heat. Please remember that there's a loss in the conversion from electricity into hydrogen and from hydrogen into ammonia or whatever. And these heat losses, let's say 20% in each step, they are so huge. If you have 5 gigawatt of offshore wind and you convert it into hydrogen, you will get 1 gigawatt of heat for free. So for sure, if you can place the electrolyzers close to the biggest cities, they can have, let's say, a long-term, let's say, a benefit from this waste heat, and it has a large impact on the socioeconomic calculation. So this was, let's say, an introduction from the European level categorization, our proposals for implementation of a new regulation, and then a case on where we are in Denmark. So thank you. I can then go to the poll. Should I do that?
Yes, thank you. Thank you for Torben for the presentation. So just give me a second, and I will run the poll from my side. Right, the poll is up. So feel free to vote, and then Torben, just walk us through the result. Yeah, sure. So right. The first question is hydrogen will in pipelines cross how many borders in Europe by 2030? Now you have seen some presentations also in mine. Is it 1 or 2 European Union borders?